Okay, everyone, here's our second example problem for chapter 7. And this one says a spring is stretched by 0.35 meters by a 0.75 kilogram object and sits at rest. And if K, the spring constant, is equal to 2.7 times 10 to the second newtons per meter, what is the work done on the spring by the mass? There was a part B that said force gravity, but that was for a different question. I shouldn't have typed it there. So we're just going to find the work done on the spring by the mass. And so what this situation is we basically have a spring hanging like the one I showed you in class. And then there's a 0.75 kilogram mass hung on it. And it stretches from equilibrium a distance of about 0.35 meters. And so when we want to look at the work being done on the spring by the mass, we can really think about the work equaling the change in the elastic potential energy. The reason why we should look at it this way versus thinking about the work done by the force is that we have more information to look at the change in elastic potential energy. And then so we're going to look at the work equaling the change in elastic potential energy, which would be equal to 1/2 kx final squared minus 1/2 kx initial squared, where x initial is equilibrium, so that's actually going to go to 0. And then we'll have that the work that's done is just equal to 1/2 of the spring constant 2.7 times 10 to the second newtons per meter times that stretch distance of 0.35 meters and then squared. And we'll get that the work done by the mass on the spring is about 16.54 joules. And there you go.